So, welcome to my YouTube channel. I am Sir Zan, and today we are going to talk about the electric flux. So, what is the electric flux? Electric flux is nothing but the electric field passing through a specific area. So, let's say we have a shape. This is my shape here. Okay, this is a shape who is lying horizontally, and okay, and it has an area. You can assume that it is an area of A, okay, surface area of capital A, and let me represent its surface area through a vector which is perpendicular to its surface. This vector is representing nothing but the surface area in the form of vector of this body, okay. So let me assume that this body is present in front of the source of the electric field, okay. So what will happen, the electric field lines will pass through this body, okay. So by if we define the electric flux mathematically, we can show it like that: the electric flux phi e is nothing but a dot product of the electric field intensity and the surface area. ठीक है, which surface area? The surface area through which these electric field lines are passing, okay. So if we solve this dot product, we will get what? We will get EA, the magnitude of electric field intensity, into the area, into the cos of the angle between them, and I am denoting this angle with theta. So what is theta? Theta is nothing but the angle between area and electric field intensity, theta, okay. So this is the theta, the angle between area and the electric field intensity, okay. So if we solve this particular example, if we let me use another color to elaborate it well, I will use another color. I will use a green color here, okay. So these lines are what? These lines are representing the electric field lines, and these are basically showing the electric field intensity, okay. So what is the angle between the area and the electric field? The angle here, if you see it more precisely, it is nothing but 90 degrees. So what will I do? I will put 90 degree instead of this theta. So as we know that the angle of cos of 90, the cos of 90 is equal to 0. And what I will get? I will get electric flux equal to 0. So we can derive from this experience that whenever the angle between, or so in more elaborate way I will define it. So remember one thing, that if a body is lying in such a way that the surface area vector of that particular body and the electric field lines are perpendicular to each other, then there will be no doubt that the electric flux passing through that particular body will be equal to 0. There will be no electric flux passing through that particular body, okay. So let me take another example. I will again take the body here, okay, and let me take the area, the vector. The surface area is this, okay, it is this, okay. Okay, good. So what I will do, I will rotate this body and I will make it horizontal. What I will do, I will rotate this body and now I will make it from horizontal to vertical. Okay, now it is vertical. So what will happen, the surface area vector is what is perpendicular to this surface. Now it will come like this, okay. So now by moving the body, the surface area vector has also moved and it has come like this. In short, what is it? Is perpendicular. If you see it more elaborately, it is perpendicular to the surface, okay. Here you can see that this angle is 90 degree, okay. So okay, again we will do the same. This is my body, and what I will do, I will put it in front of the electric field line. So what will happen, the electric field lines will pass through this body. So these are nothing but electric field lines, okay. So what is the formula of the electric flux? It is equal to phi e is equal to ea cos of theta. And what is this cos of theta? This is nothing but the angle between electric field intensity and this area. So if we see more precisely, the angle between this and this is the area, okay, this is the area, okay, and this is the electric field line. The angle between these two is nothing but 0 degree. Why 0 degree? Because both of them are parallel to each other. That's why this area is, this angle is 0 degree, because they both are parallel. So what will happen, our flux will be equal to EA into cos of what, 0 degree. So what we will get, we will get our electric flux equal to electric field intensity into the area, into the area. So what is this? This is our electric flux. Okay, so in this case, as we know that the maximum value of cos of theta is 1. Okay, so in this case we are getting what, we are getting the maximum value of, the maximum value of electric flux. Why? Because cos of theta, the maximum value is 1, and in case of this 0 degree, cos 0 is 1, which is maximum. So if it is 90, it will be minimum in the, we seen in the before case, and if it 40, it will 40 degree, 50 degree, 60 degree, it will again less than 1. Okay, so in those cases, the electric flux will be less than this one, this EA. So in this case, the electric flux is maximum. So remember one thing, that whenever the body is lying in such a way that it's the vector, the surface area vector of that body and the electric field lines are parallel to each other, it means that the electric flux passing through that body is the maximum. Okay, so now we will find the unit. We will try to find out the unit. Okay, what is the unit, what is the unit, what is the unit of electric flux? So as we know that the electric flux is nothing but equal to EA into cos of theta. So as we know that cos of theta is a trigonometric quantity, and here we will neglect its unit, it has no unit here. So we will concentrate on the unit of E and A. So the unit of electric field intensity, as we studied in our previous lecture, it is what, it is nothing but Newton per coulomb. And what is the unit of the area as a unit? It is equal to meter square. So what is the unit of the electric flux? It is nothing but Newton per coulomb meter square. So what is this? This is the unit, this is the unit, this is the unit of electric flux, and not as unit only, it is the SI, international standard unit of the electric flux. Okay, so now moving forward, I'm going to solve a simple example which will help us to understand this concept in a more deep level. So let's say I have a body whose area, whose whose area is equal to 2 meter square, and the electric field lines passing through it has an intensity of, I will take it, 10 Newton per coulomb, and the angle between both of them is equal to, let us take, equal to 60 degree. Okay, so what we have to find, we have to find electric flux here. Okay, so if I take that body, if I draw that body, that body would be like this. Okay, it would be tilted like this. Okay, so what will happen, the vector area will move in this direction, and it is the area vector. Okay, and the electric field lines passing through it will be like this, like this. So it is making an angle of 60 degree. These lines are making an angle of 60 degree with this area vector. Okay, so we know that the electric flux, let me change the color again, the electric flux is nothing but equal to EA cos of theta. So here, as we know that E is equal to 10 and area is equal to 2 meter square, and cos of 60, theta is here is 60, so cos of 60. So the ultimate answer will be equal to 5. Okay, so 10 into 2 20. Now it will be equal to 10. Okay, it will be equal to 10. Okay, so the answer will be 10 here. So here the electric flux is 10. But what will be the unit? If you go back, the unit will be equal to Newton per coulomb and meter square. So unit is very important in every exam. You have to write the unit with every numerical of the physics. Okay, so it was a lecture. In this lecture I tried to explain you the electric flux. So what is electric flux, what are the different scenarios of the electric flux, and how to calculate the electric flux, and what is the unit of the electric flux. So I hope that you have enjoyed this lecture. If you have any type of question, you can follow me on the Instagram. I have given my link below, and you can ask as many questions as you want. Thank you very much.